In barely a year, the James Webb Space Telescope has totally changed how we might interpret the universe. Various pictures taken by the largest telescope, with likely the best infrared resolution and sensitivity, have gone viral worldwide since its launch on December 25, 2021. The James Webb Space Telescope is definitely the most advanced telescope ever built by humans. The ISIM structure, which coordinates the telescope's science instruments, supplies the instrument with power, computational support, cooling capacity, and structural stability. The ISIM also houses the telescope's guide camera and 4 scientific instruments. The near-spec spectrograph operates in a similar frequency range to the fine-guidance sensor and near-infrared imager. Additionally, the slitless spectrograph is used to focus on the view during scientific observations, while the mid-infrared sensor measures mid to long infrared frequencies. The $10 billion invested in the JWST's construction has been well justified by the images and data it has sent back. On July 12, 2022, the world saw the first images ever captured by the telescope, and researchers agree they show Webb at its absolute best, fully equipped to continue uncovering the secrets of the infrared universe. The initial collection of photographs included the majestic cliffs of the Carina Nebula, the exoplanet WASP 96b, the Southern Ring Nebula, Stephan's Quintet, and a stunning deep-field view of the universe. Since then, researchers have been able to observe even more dazzling and awe-inspiring photos of the universe, thanks to the James Webb Space Telescope. There has been an explosion of cosmic publications released since the JWST's data and images were made public, and some of them have left cosmologists and astronomers more perplexed than ever. Some of these discoveries have caused widespread concern among scientists. But why is everyone suddenly so alarmed? It's because the James Webb Space Telescope's findings appear to contradict the Big Bang theory directly and repeatedly. To understand this, let's define the Big Bang. Most cosmologists agree that the Big Bang is the best explanation for how the observable universe came to be. Both theoretical and observational elements of the universe's structure contributed to its development. This model provides a unifying explanation for a wide variety of cosmological phenomena, including the abundance of light elements, large-scale structure, and the cosmic microwave background, by showing how the universe evolved from an initial state of high density and temperature. The faster a galaxy is moving away from Earth, the farther it is, which holds true for galaxies at all distances, consistent with Hubble's law. The theory predicts an ever-expanding universe, leading to a singularity where existence ceases to have meaning. Calculations indicate that the Big Bang occurred approximately 13.7 billion years ago, based on precise measurements of the expansion rate of our universe. This is a strong estimate of the age of the universe. The idea of the Big Bang is direct and clear, although the term Big Bang is widely criticized as being misleading. The infinite universe, in fact, is expanding into itself, with no center, contrary to what the term might suggest. Everywhere, simultaneously, the Big Bang occurred. It wasn't a single moment but rather a process unfolding over time. This is supported by the observation of the heat left over from these early times, consistently saturating the universe, and by the way that worlds are hurrying ceaselessly from one another. Furthermore, not from some essential issue, the Big Bang isn't something we can observe as much as we might like. However, this doesn't imply that no evidence of this exists. Researchers claim they can feel a similar degree of heat from 380,000 years ago. The whole sky and the entire universe are washed in this heat. Satellites like the Cosmic Background Explorer, Wilkinson Microwave Anisotropy Probe, and Planck allowed NASA and ESA to create a map of it. Only minute temperature changes could be detected right now in the universe. While the JWST's objective was to peer into a concealed window of time in the universe, other missions like the Cosmic Background Explorer, the Wilkinson Microwave Anisotropy Probe, and Planck have previously looked further into the past than the JWST. One of the primary objectives of the James Webb Space Telescope is to capture images of the first objects to form as the universe cooled after the Big Bang. Dr. Mather states that this time is likely many millions of years after the one the other satellites were designed to observe. According to John Mather, a senior project scientist on the James Webb Space Telescope, Dr. Mather believes that the small temperature fluctuations picked up by these satellites were the seeds from which new galaxies emerged. To find out when and how the earliest stars and galaxies emerged in the universe, the James Webb Space Telescope was, in general, the main explanation for the beginning of the universe. The theory of how things came to be states in its simplest form that the known universe began as an infinitely hot and dense single point that expanded and inflated at unimaginable speeds, and then at a somewhat measurable rate over the next 13.8 billion years, to the still expanding universe we see today. The Big Bang is currently our most plausible explanation for how the universe began. However, it appears that these latest JWST photos are prompting some researchers to question the validity of this concept. Most cosmological theorists have steadfastly supported the Big Bang theory as if it were indisputable fact for years. However, the latest JWST findings are causing experts like Alison Kirkpatrick to worry. She is a professor of astronomy at the University of Kansas in Lawrence, who claims that new developments have made her question whether her entire career has been a waste of time. It's impossible for the Big Bang theory to account for the fact that galaxies are so uniformly small, old, and abundant. The Big Bang theory suggests that the universe is expanding and that some kind of unusual optical illusion must exist in the universe. The images from the JWST show galaxies and other objects in the expanding universe getting smaller and smaller, despite the fact that past a certain point, galaxies and other objects in the expanding universe should start looking bigger, as their light should have left them when they were closer to us. A galaxy's apparent size can diminish by a factor of several in these images, even if it has a higher luminosity or mass than our own Milky Way. If the galaxies the JWST is showing us are the same size as the nearest galaxy, then the universe is not expanding. Moreover, the redshift doesn't increase with distance. The redshift of the later galaxies in the photos is several times higher. Eric Lerner and Ricardo Scarpa think this opposes their theory of an expanding universe. However, it's consistent with their theory that the universe we live in is static. Previous publications used data from the Hubble Space Telescope to demonstrate that galaxies up to redshift 5 are consistent with the assumptions of a non-expanding, static universe. Big Bang theorists who believe their theory will be confirmed by the James Webb Space Telescope expected to find galaxies extensively damaged by repeated collisions and mergers. The JWST photographs, on the other hand, showed that most galaxies have smooth disks and intact spiral shapes, just like the ones we see today. We may need to reconsider our assumptions about how often galaxies merge after seeing the data in the new release, which shows that there were 3 times more smooth spiral galaxies than expected. Using this evidence, Lerner and Scarpa argue that the merger theory can be completely discarded. However, some of the galaxies have shown stellar populations that are at least 1 billion years old, which contradicts the Big Bang theory's suggestion that the most distant galaxies in the James Webb photographs are observed as they were only about 400 to 500 million years after the beginning of our universe as we know it. The Big Bang theory states that nothing could have existed before the event. Therefore, according to the authors of the article in question, these galaxies are evidence that the Big Bang didn't occur, and there can be no galaxies older than the Big Bang. Thus, it was hypothesized that as the JWST looked further into the past and future, we would uncover more about these ancient galaxies and their formation. The quantity of systems would decrease until there were 0 remaining. After a grandiose dull period, new examination shows that universes as extensive as the Milky Way are regular even a few 100 million years after the speculative Big Bang. When seen from the perspective of the Big Bang, far-off systems ought to be innately smaller. Among the galaxies referenced in the examinations is JHCH2, which has an anticipated span of only 300 light-years. However, it is far brighter than our own Milky Way, being only 1/150th the size of the Milky Way. Lerner suggests there are various reasons, beyond the JWST photographs, to question the Big Bang theory. In his assessment, the Big Bang model makes 16 incorrect predictions for every one that is correct. Additionally, there is a lack of larger and more distant optical illusions, as well as the presence of large-scale structures too massive to have formed in the available time frame. Its prediction of helium is off by a factor of 2, and its forecast for the abundance of lithium is off by a factor of 20. Soon after the Big Bang, cosmologists and astronomers have generally agreed that all mysteries could be solved. The Big Bang theory, which was first raised in an article by Lerner and Scarpa, remains widely supported, and the most recent JWST observations have not disproven the hypothesis. These findings have illuminated some peculiarities of the universe. However, the theory is based on only two facts. First, that more distant galaxies have a higher redshift than closer ones, and second, that the universe is filled with a large background of microwave radiation. Both are two of the three main pieces of evidence that support the Big Bang theory, the third being the relative abundance of elements in the early universe. Over the years, these observations have served as the foundation for the conventional model of the universe, widely known as the LCDM model, developed by scientists based on these ideas. This scenario is supported by the observed acceleration of cosmic expansion and the clustering of galaxies. In a static and non-expanding universe, the Tolman test predicts that all galaxies, regardless of distance, would have the same surface brightness. As seen in the JWST photographs, the surface brightness of more distant galaxies is lower than that of closer ones. Redshift is often used in these images to support the illusion that galaxies are receding at an ever-accelerating rate. In reality, distant galaxies are not plunging through the void at breakneck speed. Instead, the expansion of space itself is increasing the distance between us. This distinction highlights that cosmic expansion, rather than relative motion, is responsible for the cosmic redshift. The results from the James Webb Space Telescope are not entirely consistent with predictions made by experts. The Big Bang scenario has been widely reported as being challenged by the data gathered by the extraordinary James Webb Space Telescope. Astronomers were expected to uncover such perplexing data, possibly explaining why so much was invested in the telescope initially. The JWST images appear to have sparked more than mere thoughts about the Big Bang. Encouragingly, the telescope found a galaxy that existed around 13.5 billion years ago, just a few weeks after the first JWST images were released. The Glass Z13 galaxy dates back to around 300 million years after the Big Bang, which is 100 million years earlier than anything previously detected. We may be looking at the farthest starlight anyone has seen, according to Rowan and Naidu of the Harvard Center for Astronomy. This was observed in the NIRCam data released early by the James Webb Space Telescope, converted from infrared to visible light. It appears as a red mass with a white center within the larger deep-field image of the universe in the background. Scientists have indeed found something surprising in their analysis of the James Webb data. This galaxy has the mass of 1 billion suns. However, they expect to learn more when the telescope's network grants them additional spectroscopy time. Are there even more ancient galaxies out there? Do you think Lerner and Scarpa are onto something with their theory of a non-expanding universe? Thank you for watching this video until the end. Did you like this video? Leave a like and subscribe to our feed to stay updated on our new video releases. We have another interesting video ready for you. Tap on the video on your screen and let us bring you into another breathtaking space adventure.